Hi, everyone. For my second significant contribution of the week, I decided to do an oxymercuration and demercuration reaction problem. And as far as the tip of the week, too, I was also thinking about this. I think, text discussions are really good, but I would definitely encourage video just because you kind of force yourself to think through the problem. I know sometimes I can watch some video lectures and think I understand something, but then when I go to do them, I really kind of get stuck and I realize that I don't actually know how to do the problem as well as I thought I did. I just kind of watched the video and I was following along with what, the instructor is saying, but and I was understanding what they were doing, but there's a difference between understanding and being able to actively recall and know what to do the steps of. So let's go ahead and try this problem together. So we know we have an oxymercuration problem, so we are going to have oops, I'm terrible with this pen. I'm so sorry. Mercury diacetate, and obviously the di meaning two. And we will also have water. And lastly, NaBH4, um, which we'll use at the end to get rid of our mercury. So these are our tools, so to speak. Tool number one, tool number two, and then our very final tool is number here. So let me go ahead and just draw quickly a representation of what we're looking at here. Okay, so our double bond is going to attack our mercury, and what's going to happen is it's going to kind of get stuck in a ring structure, just like we saw um, with our halogenation problem we did in my last video. Oops, sorry about that. And you'll notice that we only, instead of having the diacetate, we have only one. And that's because when this double bond right here came and attacked the mercury, it kicked off one of these acetates. Okay? So we just have one here. Now, this is that very unhealthy, unstable cyclic structure that we talked about before. So that's where our nucleophile water comes into play to be our number two in this situation. Remember, we already used mercury. Now our water is going to come in, and it's going to attack the more substituted side, and it's going to kick off the mercury. So let me scroll down a little bit here. Actually, I can't scroll. I might just have to draw it again here. Okay, so we have our methyl still here. We still have our wedge here. We have our mercury on this side. And I won't draw the acetate just to save time and space. And also, I'm very slow with the pen here. And now what we'll have here is we'll have our water. Now, of course, every time water or oxygen, I should say, has three bonds, it's going to be a positive. But no fear, this will be deprotonated, leading to this structure. We have our alcohol. And then lastly, our number three can come and kick off the mercury that was right here, leading to just a hydrogen. I probably should have been a little more clear about that. So let me draw that again, and I apologize. It's going to come right here, and it's going to kick off the mercury that's right here. And again, that actually has a acetate. I just didn't think I had enough space, and I barely do. And that's going to just leave this hydrogen. Now, and because we now have a chiral center here, This can be on a wedge or a dash. For the heck of it, I'll put this on the wedge, and I'll make this methyl into a dash. Okay? So when we're looking at our answer problems here, we're going to be looking for something that looks like this right here. So our first answer choice has an alcohol on both of the carbons of the double bond. That makes no sense. The second answer choice, all it did is move the double bond over. It didn't actually do anything else. This is the original molecule, just with the double bond moved over. That is definitely not right. This one looks pretty similar to our answer here. We have the alcohol on either a wedge or a dash. In our case, we put it on the wedge, and in their case, they also did. But we have our hydrogen on the other, which it won't show because that is implied. This is not a chiral center. It's just a CH2. So this is the right answer. Let's make sure D is not something interesting, and it's not. It doesn't show alcohol at all. So C is definitely the right answer. Let's go ahead and click check answer, and that is correct. If you have any questions, please feel free to let me know, and I'll do my best to help out.